I'm still happy to have you all in Zoom. Yeah, lucky to have Zoom opening. So I thought, oh, should I open the Zooms? But okay, so I did. I think I need to share the screens, right? So that you can see it. Let me share that. And also, I need to close some of this smaller. And I think, oh, this is. Um, this is a Visual Studio Code. Sometimes I'm using this, but we're not going to work on this, right? Maybe later, but not today. Today we will work on. Let me clean up a little bit of this. We're going to work on Colab. Okay. So let me first get the Colab. The one that you could get. Let me repeat, just in case if someone is not yet ready. Then go to your uh, the Blackboard class Blackboard, where you can see download here. There's a today's lab IPNY format of a file, so I can download it. No, and click this and download it. So it is downloaded, and I will come here and then open the file tab where you can upload upload button and the browse to your computer. Since I just downloaded it, I probably get that from this downloads button. And then there is this one. So we'll take that up. Okay, this is our lab for today. Before we get to that lab, we need to do some of the concept learning. Oh, by the way, before I forget, our midterm exam will be scheduled after, well, rescheduled. Originally, I would do that before. Oh, I have one more student. By the way, should we meet? Should I come here to the classrooms continually, or all of you guys may like to join over Zoom? Let me get some polling from you guys. You guys
think
want
Zoom.
me to open Zoom throughout whole, not necessarily whole semester, but for a while? Is the Zoom
Yeah.
better, you guys?
Yeah, Zoom is better, Professor, for me as well.
What do you think? The whether I like a Zoom or come here in person?
I think you like in person.
No, I like Zoom also.
Really? That's
Yeah,
great,
how
Professor.
should I come here? I mean, for this, but no one's with me. Then why should I come here?
Yeah, my only issue is Professor commute because I live in Queens and
Oh
it's
yeah,
really,
that
yeah, it's so difficult. That's why.
understand. Okay, understand. Yeah, yeah. Except Gianni. Gianni said, "Oh, I'm close," but that's okay. I think Gianni is sick today, right? Not physically. Okay. Then I will do, yeah, from time to time. Like this morning, the weather was really uh, not good and pleasant enough for me to walk and sitting on the train, looking outside the Hudson River, uh, all drizzling. It's not snowing either. Anyway, so I came here for you guys, but I cannot meet anyone of you, but I can meet you over Zoom. Still okay. So I will do the following. If I do not want to come for some Tuesdays, then I will post that early in the morning. So don't come for no purpose. So before you come, if you really want to come, then you let me know early, a day early. Hey, Dr. Yun, can we meet in person in the classroom? Then I will definitely come. If I don't hear that, and also on that day in the morning, if I don't feel well or the weather doesn't look clear, I like clear weather. I don't like rainy days, windy days. I don't like snows unless it is not. Yeah, if it is not snowstorm or simply falling snows, I like it. But other than that, I don't like either. But anyway, then I will post. I will email you guys on Blackboard. Hey, today let's meet on Zoom only. Or yeah, if I don't say that, then I will come. Okay. If I don't say anything to you guys, then anyway, I will come here in person. So if you don't hear, but if accidentally you want to come in person, please come. Is it clear, you guys? My plan? I was just thinking of right now. I think
Yes,
it's clear,
Professor.
right?
Yeah,
Yeah.
it's
Yeah.
clear.
If you don't hear anything, then I am here so that you can come. Also, I will open Zoom for you guys to join me. Maybe once in a while, I will email you, hey, let's meet over Zoom only. Then, as usual, we meet over Zoom. If I prepare only on Zoom, then I'm more comfortable because I can sit on the chair. Right now, you guys understand this classroom settings, right? I need to stand up. Right now, I'm standing right here, and I'm looking toward the wall where my projection screen is on. But projections is not really ideal. Okay, I think I talked too much. Something unrelated to this one. Okay, today we will do the conditional statements and then iterative statements. Two things together today. Okay, so today is again I think busy, so we have to go faster. If I don't explain much here, you can do on your own here. If you don't understand it, you can contact me. Okay. Let me start with the dictionary definitions about condition. Condition is a state of something with regard to its appearance, quality, or working order, or anything that can be proved either false or true. So in mathematics, it is called predicate, right? Predicates. So conditions can be written in a predicate. Therefore, we can evaluate it to either true or false. There's no condition say, hey, I don't know. Then that is not the condition for the coding. Coding strictly, we have to get either true or false from the conditional statements. So it's like that. And then simple conditions that I put there. In language, we use if, else. and if followed by condition, and then there is a some of the marker, colon. So it tells me after this, then we will have the action block. By action block, it's not necessarily one actions. It could be multiple actions. Series of actions can be followed, can follow after this colon. Okay, if condition colon series of actions. If we have else, then else. With the else, then you don't put condition. Immediately after else, you will have a colon for the necessary action blocks. So we have actions, other actions. We can expand this further if we have, in this case, we have only two cases, right? Whether condition becomes true or false, two cases. But if we have multiple conditions, then we can say, if this condition is true, then if this condition is true, there's one case. Or if that condition is false, but another condition is true, we can continue this. If first condition is not true, second condition is not true, but the third condition is true, then another actions. And we can continue to that. So this elif is not only one time, it could be multiple elif. And finally, else. You better have else, unless otherwise, what happens? Conditions doesn't cover entire possible spectrum, right? That is somehow vulnerabilities. You should put else. Therefore, otherwise, all others, then we'll take care of that also. If you don't take care, then it'll be taken care of by attackers. So math predicates 21, for example, if age is greater than or equal to 21 and less than or equal to 36. I said and, right? When I read this. For this case and that case, I said and. So if we split this, then we need to have this and. In earlier, the coding languages, this is not allowed in coding languages, only this. At that time, this operator, the whatever operator here, if we have an operator here, then we will have two operands. And that operands should not be shared with another operator. This type of statements are not allowed, but in Python, this is allowed. This is okay in Python. This is okay too. Both are okay. Okay, so you can say this is nothing but like this. Either if age is greater than or equal to 21 and age is less than or equal to 36. When we read this in mathematical, then we read it just like this, right? Age is greater than or equal to 21 and less than or equal to 36. That's the way that we read this. the way that we read can be written like this. So this is the earlier the language, the acceptance, but now it says, however, it works in Python, right? Python accepted this. Condition can be formed in this way. We have an operator, right? So we have two operands. In this case, this operator is called the binary operator. So one operand may be variable, the other operand the value. But anyway, in any way, when we evaluate this operations, these conditions, even if this is a variable written in variable, it should be evaluated, meaning the value should be considered. The value contained in this variable should be considered. So the two values can be compared by this operator. Even if we have two variables, still those two variables should be evaluated. So that's called evaluation. Right? Or one variable, if it is Boolean, bool variables, the value is in bool, so it could be either or false. So variable like this, red light, that we already know if it is red light or not. So true or false can be evaluated by these operations, by these expressions, right? The others, very typical. Age is greater than or equal to 21. If height is less than or equal to depth, height and depth both are variables, right? Looks to me variables. Therefore, if height and depth already declared and so hold value, then that value can be used to compare. So that is the simple conditions. We have a complicated conditions comes, right? So we say, so we have an input function. This input function returns the value which is typed from standard input device. Standard input device is keyboard, right? Keyboard. And then type of that value returned from input function is always in string. Although we press the number buttons in your keyboard, it is still taken in string. Your keyboard, all the keys there are not distinguished whether it is integer or string. Everything written in string first. So input gives you string and take that data in string. If data is greater than or equal to 21, this is a condition, right? Data, as I said, that is in string. String should be compared with the number. Impossible, right? So you have an error. But anyway, therefore we have to put something here, right? After you input, then we need to convert this string to integer by having another function int. There's another function. So everything about that input function should be inside that input functions. Then it'll be okay. So we can have logical conditions, and so instead of ampersand, Python prefer to this. Okay, our English language. Conditional statements. So if else, yeah, like that, and already that. Okay, so that much that we can see. So conditional statements is simple. So once we know the condition, the cases or situations that we want to describe to evaluate to get the either true or false, then that is the conditional statements. I want you to get the Google Colab. So everybody has Google Colab. So I explained the predicate again here. And will this be, what is, let us practice. This is a code, right? If you place your mouse a little bit above that box, then that is either, you can open another code block, code box, or text box. So for example, if you can text box, then you can say my practice. After that, under this, I want to open code block. And then if I want to say 5 is greater than 3, this is condition, right? 5. I mean, 5, this is a greater than operator. What if we do like this without parentheses? And I want to evaluate this. Evaluate it. It returns true, right? It could be okay if you put that's true. So you can get, for example, your age is, yeah, come from and then print that age. And then I want to see the type of that age. Then say 18. I printed 18, right? What is the type of that 18? It says a string. If you want to see the type, then you need to say type age. All right? So if I say if your age is greater than 21, then I would say print by alcohol, otherwise you cannot. Okay? We'll put here equal sign and the put and the run. And if I say 18, Okay, by this time, because this is age, it's still string character, so it cannot be compared with the number. So what should we do? We need to convert it to an integer. So using the int function, if I run, for example, 21, then 21, age 21, what is the type of age? Now it says integer, right? Because I converted it to integer. And therefore it can be compared with the 21. So which number that I entered? 21. Is 21 greater than 21? No, it is not just greater than 21. It is equal, right? Because I don't have an equal here. So you cannot. So you are permitted to buy alcohol only if you are older than 21. If that is the case, then that condition works. Or if your law says your minimum age is 21 for alcohol purchase, then you need to put the equal sign. Therefore, if you put 21, then yes, you can buy alcohol. Okay. And then there is another ones in the list. Remember that we looked at the list. So another code saying, I'll copy this. Consider the list. And oh, I simply use this. Why should I use? So I want to say this is the first element. A second element, if we have wait a minute, did we have data types? Sounds like, oh, we had the data types. Let me see. Data types. Oh, we had data types last week. Oh, we did that. I'm confused. Okay. So we already, yeah, then this is perfect. So this is a list. List can be accessed by index, right? So order, so list is nothing but an ordered sequence, ordered list. It's not like dictionary. Dictionary, it's not like that. Do we have dictionary things here? Okay. So another one, for example, if it is dictionary, then sequence of, for example, 505, then that is foundation. And 500, that is, what is the course of 500? All shallow. Everything in shallow. So that is the introduction. And for example, 520, then that is data mining. I'm talking about the course list. It doesn't matter with the order. So we can put here, for example, 525, and that is database. And the 550, 560 is wireless network, and the 555 mobile computing, like this, right? So that is the dictionary. Yes. Because of this guy. Okay, here. So I can access any one of those. I cannot do, for example, if I want to access mobile computing, I cannot do like this by indexing numbers. But this is the value can be accessed by the key, because a dictionary is a set of key and value pairs, right? Key and value pairs. So values can be accessed by key. So if I want to, for example, 555, and if I run this, then I can get mobile computing, right? It's not like this. And similarly, if I say here, if is or you can say is. Print yes, otherwise no. If you run this, no, it is not. What is this? Oh, this one says equal equal. What is the messages there? Syntax warning is with the string. Oh, if it is a string, not recommended to use the English language is rather than double equal sign. I don't know. I don't know why. But anyway, the Python likes this. This is a dictionary. If you have a dictionary value can be accessed by the key. If it is a list, then list or tuple, then it can be accessed by the index. Index means the order of that. The numbering starting from 0. So if we have number 1, then it'll be pointing to this second element, which is, if this is evaluated, then it is nothing but number 8. Now we compare number 8 is compared to 4. So in this case, we better to put here. But this guy may not complain, right? Because this is an integer rather than equal sign. And I wanted to okay. So not even that. It's not really the error, but warning. Okay. If we do this guy. Okay. So if we have this, then it returns false, because number 8 is not equal to number 4. And another comparison here, because this is all conditional statements, it should return either false or true, right? That is the main point of predicates. Length of a list. So we know one number. What is the length of that? The length of this list is number 4. because there are 4 elements. So 4 is greater than or equal. As I said here, what did I say? Right? So it is not greater than, but it says we have or operator here, not operator, our understanding, our reading, right? As we read, this guy evaluates, right? So either it is okay if even if it is greater than, still okay if it is equal to number 4, right? So anyway, it is okay. So it returns true. Lastly, there is a function called the index. This Google Colab is intelligent assistant. When I place my mouse over that index, says it is a method. It is a the method implemented that way, and then it gives me the signature. What that means is the value of an integer takes, and if there is a start and stop, okay. So maybe three elements, 3 arguments can be taken by that index function. When I move this, it'll be disappear. Oh, it's okay. So I'm talking about this value integer. This is the first element, first argument, first parameter for this function. Start is the second parameter, and then it explained what is the start. If you don't say anything, then it'll be 0. Stop is the maximum size. So this integer, consider a specific number in between this start and stop. And then it returns integer, which is the index integer, where there's a position number, right? For example, here in this number 9, where is it placed? It is in the 4th number. If it is in the 4th number, because the number is counted from 0, so index number is a 3, right? This will return 3. So if 3 equals 3, so it says true. So I want you to practice that, and then we already if and else. If, for example, can I buy alcohol? Then say enter your age. Depending upon the age, for example, if it says 23, then true, right? I want you to see here. Is there any if else statements? No, there is no if and else statements. But still we know the true. We can make this decision, right? Because this guy, we don't put there if else statement, but simply we print it. But because that expression returns bool value, so that is a Boolean expression, that is okay, just like we have a Boolean value from the evaluation of if-else statements. So regular conditional statements returns bool values. In the same way, if simply with no if-else statements, only the expression of that, then it returns bool values, like a predicate that we learned earlier, right? So return true. It's not like if then else. This can be written in this way. Exact same ones can be written so that if we have a 2-1, it says yes, you can. But earlier, simply says true. Can I buy alcohol? True. Perfect, right? Can I buy alcohol? Yes, you can. So more explanations. If we use if else statements, then we can explain more. With this only, there's no explanations, but the final result. True or false? So there's a homework assignments. Write conditional expressions for each of the following statements. Range and visibility constraints. Score is between 60 and 100 inclusive, and it is a multiple of 10, and use the variable score. So I want you to do that. One of the example there is, in this case, say score. Score is between 60 and 100 inclusive. So we can have inclusive 100, and here is greater than or equal to 60, right? This is one predicate, can be combined with and score. This guy gives me already. So, and also it is a multiple of 10. If it is a multiple of 10, then this operator, percent, which is a modular operator, it returns the remnant. If it is multiple of 10 and divided by 10, then there's no remnant, right? 10 divided by 10, there's no remnant. 100 divided by 10, no remnant. Although we have different quotient, right? 30 divided by 10, then quotient is 3, there is no remnant. So if we say score percent modular 10 modular by 10 equals 0, which means, oh, if it is a multiple of 10, right? To make this more sense, then we need to do score equals maybe, oh, we can put the user interactively. We don't need to if and else, simply run this. Say 50, then it's not greater than 60, therefore it is false. First predicate is false, so entire false. Although score, this 50 is a multiple of 10, although the second predicate is true, but because the first predicate is false, and because we have an AND operator here, AND operator means both of those should be true. Only in that case, this AND operator will return true. But because the first one is false, so entire will be false. That's what it is. If we run this again, for example, 77, then still false. 77 make this first predicate true, right? 77 is in between 60 and 100. Through this AND operator, the second predicate becomes false because it is not multiple of 10. If we divide by, for example, 7 is 7 modular 10, and if we run it, then it returns 7, right? 7 is not over course 0. Therefore, because of the second predicate is false, entire false. If we run this, for example, 70, then what? It'll be true, right? Finally. That type of things. I want you to practice this. I put there some variables that you need to use. Okay. So 4 of those. I want you to make that. Okay. Any question about the conditional statements? Anybody can answer to me?
No, I'm all right.
Okay, good. Iteration, looping. We have, I want to see here this. There's some condition. If it is false, no, this is not iteration, right? No iteration. Sorry, wrong. It should be iteration. Some condition. If it is true, then stop. Otherwise, update. And come back. Some of the conditions. If it is true, update. If it is false, stop. Iteration, right? Repetition statements. Repetition statements is really needed in codings, in computation, in computing. That increased computing power. If we need to do some work, some sequences 100 times, 10 times, oh yeah, I can do. Human can do. But if it is 10 million times, somebody can do, but not all. If it is 100 billion times, no one would like to do, right? But AI can do, computer can do, because that is the power of computings, the iterative statements, some of the iterations. So it is like this. Some of the iterations comes here, and then some values can be smaller and smaller. When it reaches some conditions, that iteration will end. Another case, initial value comes, it becomes bigger and bigger, and then there is some condition says it should be less than that. Then that is the terminate condition. That is the terminate conditions, and it'll end. So in the iteration, the termination is important, right? In the iterations. The typical codings, termination is the key. So when I learned the codings decades ago, the first thing that we need to be aware all the time is that your looping conditions should terminate. So you should make it terminate. These days, termination is one case. There is so many other useful cases if it doesn't terminate. What is the case of that? Some of the sensor technologies, sensor, that's a device that should sense continually, right? If, for example, if we have a motion sensors, so it detects. So one time detect, then it stops. Detect, then that is a good condition for terminations, but should not stop, right? Continually detect, 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 detect. That determines the robustness of that sensor computer power, computing power, can be determined by non-termination. But anyway, in our simple coding, termination is important. Many of the current the language interpreter or compiler, so there is a special treatment from that language itself. So although the coder, developer, forget to terminate it, if it runs continually, then sometimes it stops by itself. It collaborates with the operating systems. So language Python interpreter can collaborate with the operating systems and make it terminate, right? Otherwise, your computer will become if it is a low power, then it is okay. But it is a high power, it will be dangerous, right? It heat up. But usually computer power, that is a 12 volts or lower. So there's a low voltages. Even if it heats up, it takes a longer to heat up, really, to burn something. But if any other devices that requires minimum 100 voltages and it runs continually, if there is no vent systems, no cooling systems, it may heat up quickly, right? And burn. Burn what? Entire building? Entire country? Dangerous. Iterative statements. There are so much things for a number of times. So we can say, hey, do this 10 times. Second case here, do this 10 times. This is for each in a list. Hey, you grade everything submitted. So although we don't say how many, but all the submissions, then submissions, that is a limited set, right? So depending upon the given sets, can continue. For each element in a file, so the size of file varies. One file from another file, the size highly likely different, right? So we cannot say how many times. We simply say as far as something in the file, do this. For example, read words from given file and count how many words. Then, so file operations requires loops. List requires a loop. Explicit number requires a loop. These are the for loops. And we have also while loops. Rather than saying for, we can say while this is alive, do the same things. particularly if your program handles data from the internet, then while data available, you handle it, right? It's a typical case of the number, right? We have some range there. And then if we have a list, then given the list, and we can say for each in a list, then each is a variable. So each can be used. So each is not resolved word. For is a resolved word. So for in, those two are resolved word. List is given list, and then inside of this for loop, you declare the variable so that you can say, hey, I'm going to use this variable to take one element at a time from this list to handle. Another one is the file. For each in F file, print that. So file is that, then you need to see what file is, right? File. And then while loop, instead of describing some conditions, you can say while true, which means I want to run this continually, like a sensor technology, while true. At some conditions, you can break this while loop. If no power, then you break it. So iteration is like this. An example, the while loop. Value equals 1, total equals 0, while true. If value is less than 10, we add them and increase the value, because this is if. When this is okay, then as far as this condition is true, then we do this two actions continually. And if the value is greater than, because the value is increased, right? Value is greater than 10, then we go to else part, and that is the end conditions, and then we break that true conditions. So this guy will break this, right? For each, if a list, this is a string. String is nothing but a list of characters. So for example, if we have for each in list, only this, and print each. So what will be printed? It'll be M space E all C Y, or it'll be M E all C Y. What do you think? Can anyone say? Number one or number two? if you want to try, you can try. Do we have that? Yes. We can practice here. LST equals mercy. If I say, oh, this guy already got that, and then I run it, this is the answer, right? Because as I said, if we have this string, then string is nothing but characters. If this is only, it's not the case, for example, list 2 equals another list and say 2, 8, 12, mercy, or length of mercy, or mercy and then 2. Oh. First of all, when I print LST2, what it would be? Up to this, okay, all elements fine, right? Well, actually up to this, homogeneous, no problem. Someone may think, oh, confused. Why the integers comes with the string? Still fine in Python, because we do not declare this list is whether a list of integer or a list of string. As far as there is a file given, then we take care of it. That is a Python. Length of mercy, I do not know. Mercy in string, and I put there the index, just like a list. I do not know. Let's see what happens. So here, up to this, okay, as is, right? Length. Someone may say, oh, length, then it could be one string, number 1. No, it is not, right? If there is a string only, and if you treat it as a list, then it can be treated as a list. If it is a list, then there are 5 elements, so it gives me 5. And mercy is standalone here, and then just like when we access a list element by an index, then we use square bracket with the number inside. That's just like the way of the accessing list elements, right? So then this is nothing but, this is not just a string, but it could be a list of characters. If it is a list of characters, then this is M is the first character, E is a second character, R is the third character. This, the index 2 means third character, so R will be returned. And then we can make a for each, like this. For each data types. If we have a dictionary, then we can say for each in dictionary. This is optional. Olden Python interpreter doesn't allow this. No. For example, if we say this, let me give you some of the dictionaries if we have somewhere. Do you have some dictionaries? Okay, here, the dictionary. Let's see, this is a dictionary. This is not. Okay, here. This is a dictionary. This is a text, right? This is. And then if we do for each, or you can say for I in devices. Previously, we need to say keys. Oh, by the way, what is the keys? So for example, devices, keys, then it returns the list of keys, right? So you need to say, and also in this case, if we have a list, then clearly you can get this. So if we want to make a for loop for each in list, so that you can print this. So very nicely, Wi-Fi is in 802.11, BT, so Bluetooth is the Ethernet. The order is not important, right? If you have a small number of pairs, then you see in the same order it was defined in your list here. Ethernet first, Wi-Fi second, BT third, and the wireless. This is well formed, right? What if we do not have this list? Can it work? Fine, right? It works fine. When we do this, so what happens? Still fine, right? It has been improved. I'm not sure it is really improved. Some formality of the language itself became more flexible and flexible. So less formal. Devices dictionary. If this is the entire dictionary, how do you know that EA is nothing but key only? In this case, that returns key only. Print EA. See here? It returns key only. Ideally, if we say this for the entire dictionary, and then if we say for considering each of the element in this dictionary, I would say all of this, right? This is one element, and next is the second element, and third and fourth. Therefore, earlier interpretations, we need to put here keys. We want to put keys only out, and then because this is not a list format, we put the list, right? This is more formal, but anyway, this reading file. Reading file is really, really important in most cases. but the problem is where the file is located. Are you going to access the file? This is this Google Colab. This program is in the cloud, right? If file is on my laptop, do you want the Google Colab access your laptop? Technically possible? Yes, it is possible if you set up some. Do you want it? No, right? There's a lot of security issues. So practice this. It's not really ideal, right? Well, still we can practice it as if in one device. For example, here, which one that I need to see? I think files. Okay, then as if this is in my file. Okay, so in my given the Colab, there's some files available. So we're going to play with these files. Okay, as if we are this runs on our local device. The language remains the same. There's a built-in functions. It's not the method associated with the file. It's a built-in function. Open, like print, input, int, format. Built-in functions. This is built-in functions. Takes file name, at least the file name. And then second parameter may be the mode. So those are the modes. If we put R in quote and unquote, could be double quote or single quote. If we say R, then I want to open this file for reading. If we say W, hey, I want to open this file for writing. If we want to say A, then I want to do read and write, because the existing file for appending plain text, which means open the file, so read. As you read, you want to add more, which is write, right? So if you want to read and write together, then use A mode. So I'll be open reading a binary data. If you say B, then there is a binary. Are you going to read? In what case do you need to read in binary formats? If it is images, photo, if it is video, audio, right? Then you need to read in binary. Or you can write it in binary. RB, WB. Reading a file. There is a suppose this is a file. Read the file. We can do this is a built-in function. Open temple file. Let's say this is temple file dot. If you do this, open it and print, then you can print it. Okay. For this open the file, if it is open, then file pointer G is nothing but when you open this, G this doesn't G is not variable, but G is a variable. G doesn't contain everything of the files. Like, remember that I explained the last week when I use a drawer, when I explain about the variable and value, then drawer, then there is a label, and then that drawer contains the values. So in order to get that value, you need to use the label of that drawer. So label is nothing but a variable. I explained that way, right? More precisely in that case, what that label points, I said the label is a container that contains the value, right? In real memory, I believe I put in the memory map, then for example, this is my value, then my label here, this label points, right? That's what I did. This is a file, so we have long files. This long file is contained in a container. In reality, in memory mapping, it is not the case. Although we can start to thinking that way, but in reality, that label points to the first starting point of that. So G is a label, it's a variable, points to, we call this a file pointer because we are dealing with the file, right? Call that file pointer. G points that starting point of that, whatever the memory size that is, right? Okay. So you can, if you want to print, then it prints everything of this from these points. You can do for loop because this is a file pointer like a label. And then file is nothing but, we don't say a list yet, but like a list, some settings. So in that container, so I want to do for a variable in that container, and then I can print that variables, right? So let's practice some of that here. So what you need to do, so for loop, file. Okay. So I can say G is open and I want to open something. So in this Google Colab cloud server, you need to access the file that's available there, right? So I can say, hey, I want to read, for example, readme.md. What is the file format of this? It's a file tongue. Hopefully this is a plain text files. And then if you place your mouse to the end where there is 3 dots vertically. Open that, and it says copy the path. Okay, copy the path. So path expression, even if you're working on your local computer, you need to get the path expression that can reach the file itself, like this. So in this, the Google Colab, there's a /content /sample data /readme.md. Looks like this file, right? That particular file. So there's a file expression. So this, path expression. This is a path expression. The expression format like this here is very similar to the expression that you can see in Linux file format, file structure, right? In Linux, path expression just like that. Okay? But only in Windows operating systems, you put their, for example, device name. So C drive name, C : // and then path expressions, right? Or D : or if you have USB files in a USB device, then whatever the letter indicating that device, that should be used. That is a Windows format. But in other than that, for example, Linux, Unix, Solaris, any like this. So this is very typical path expressions. And if you want to do a print G. Okay, let's run this. Oh, we need to put here quote and unquote. This is the same as others also. So that we have some of the data there. This is simply gives me pointer. Do you see this is pointer? As I said, like pointer. When I said read, print, that gives me pointer. It's some of the pointer. This it's not really read yet. So if you do read method run, then you can read it. So this is the content of the files. This directory includes a few sample data sets and blah, blah, blah. This is the content of that. Okay, actually that is. And then if we say for each in G, and then print each. And I want to do here print. I want to do this, say, 10 times. Do that, and then 10 times. Oh, nothing, right? Didn't do anything. What if I, for example, comment this and run? Oh, I have this, right? If I include that, because when I do this, the first print statement is this, right? Dash equal 10 times, and then print statements. This is perfectly fine. I want to do this one before this line and one after that line. 2 times of print statements. Then when I do this, Then after this first one, it stops. Why that happens? When I read this, read the statements, it reads this. This is a file pointer, right? When I read this, file pointer is moving, right? From here, or as I scan these files, it moves. When I read it on, when I reach the end of this file, then this file pointer points not here, but it moves all the way to the end, right? It points to this. What happens? I read it, and after I do this, first print statements, the variable G file pointer points to the end of this. There I said another print statements, and then I said for each in G and print each. From here, there's no more, nothing left. Therefore, there's nothing left, right? So what should I do? When I scan through to reach the end of that file, if I want to redo, then I need to move this back to the first pointer, first position of that files. We call that rewind, right? Remember that probably you guys have never seen the real tapes. Real tape, it scans in sequentially, right? It runs. And when it reach to the end of that, if you want to re-listen to the music which is in that real tape, then you need to rewind it. Probably when you were young, maybe. A cassette tape. When you listen all the music in that cassette tape, and that is the end of the cassette tape, can you continue to listen? No. Before you continue to listen, you have to point it back to the front positions. You need to bring it back, right? So that is here. So that G, and then there is a sick. I want to seek to the point 0. When I read this, because it reaches to the end of that file, I want to rewind it. The language for that is g.seek, and then continue to read. And I want to run this, so that I have this, and then continue to have that, right? 2 times of those. That is this. And I explained it here, right? This is object wrapper data in response to print G, which is not readable, so we need to read it line by line. That's a simply pointer. Read the file, print as a whole, print line by line. Question is, what is G? G is a pointer. How to use it directly and using a method. You can read it directly, like a print, or directly in the for loop, in 2 ways. How can you use it? For each in the file pointer, or like this. Open it. 3 kinds of read. File read, read lines, split lines. 3 kinds, right? So I want you to practice that. We did that read, but what if we have read lines? And I want to do like this. Read And then I want to do seek, wind it back, and then read the lines. Okay, let's try to run this. So first one is first, the second one we looked at that, and then fourth one here. When I do here, read the lines. In one, remember here, this is open symbol, square bracket for a list. So everything in a list, one single list, and then finally end. And each of the lines, it says this is a dictionary started. This is one line, and then this is the next line. So what happens here? This is that. This is one line. End of one line, right? This is one line, which is one element. And after that, simply one extra line. See here, comma, right? In the list, comma is the delimiter. So this is the first element, and this is the second element. What that means is that because we no. This is the first element. After that, one line. This is one line here. After one line, this is the first line, and second line, and third line. See here, this is first line, and second line, and third line. Third line, this is the first line and second line. Third line, start from star, and everything that is in one element. From start to the end, before US, there's one line, US, and then next line. So if you see here, US, here, after this, then there's a second line. This is the first line, second line, and third line. This is the fourth line, and the fifth lines. What happens? Okay. Split lines. We can practice that also. I want to copy this, and that here split lines and run it. No, I have to do this, right? One, two. I'll put this 1, 2, and 3. Okay, run this. So I have a 1 here, 2, and 3. There is an error. Object no attribute to split lines. Split lines is available. Oh, we have to read and split lines. Right here. We have to read first, and then split lines. 2, and 3. See the difference? This is read lines method used. This is read method, and after that, split lines. So difference here. It has the special characters, backslash and n. But if you do split lines, then there is no backslash n's. Simply the characters only, right? Readable characters only. If you want to deal with the readable characters only, therefore you don't see backslash something, some escape characters, then you can use this split lines. So all kinds of beauties available in this file. Oh, we practiced that already, right? Right. How can you get this? The methods available in file. You can get, for example, Python 3, and then help function, and then you see file. Open. Open file and return a stream. So what about stream? File. Some more. Open file, return stream. Stream is not a file. It's not the type. So we don't see that. Okay. So how can I see the? Okay. I got the idea. So after that, type of G. I want to see the type of G. What is the type of G? Oh, this is the type. Text IO wrapper. So we can see text IO wrapper in our helper. So probably here. Let's see. Text IO wrapper. Okay. So you can get some. Okay, so method close, detach, file flush is ATTY or interactive stream. So read that what we read here, right? This is a file type. What is a file type? File type is underscore IO dot text IO wrapper. That is the file type. So that file, this is file type. Therefore, there is nothing but a class in object orientation. So there is a class definitions. If it is a class definition, there is a method developed. So one of the methods is read, another read line, so on and so forth. So if we have a read, then read at the most size characters from stream, which means read everything, right? Read from underlining buffer until we have size characters or it hits end of files. So read everything. Readable, read line, read until new line or end of files. If you have a read line, then read one at a time. So nicely back here, if we want to do this read line, you can see the difference. I would say this is a 4 and read the line, not the split, but read the line. Read the line is one line. So let's see. I think this is returns one line only. Number 4, read one line. This is for each. If we don't do this, then 4, read one line. And then if you do go sick, say 5, see what happens. Oh, sick 5 and print. Read the line. TXT dictionary includes that. So read one line, right? And then I sick 5. So this is 0, 0, 1, 2, 3, 4, 5. So it reads again from this dictionary. Dictionary includes that. And it stops here. Because read the line, it reads line by line. Okay. I think this is it for today's class. And I think you have the homework assignments. There are problem 3.4, while loop 3.5. I think five homework assignment, 5 problems that you have to do for this homework assignment. So I'm going to describe it nicely and then post it on your Blackboard so you should not miss it. Okay, question. Question?
I think everything is good, Professor.
Oh, good. Thank you. Okay, then I will stop sharing. Okay. I'll see you guys next week, either here in the classroom, either face-to-face, someone, or maybe in Zoom, everybody virtually. So thank you for coming today, and I will see you next week. Have a good.
All right.
Goodbye.